Density. In classical mechanics, density is a key concept that describes how mass is distributed within a given volume. It plays a significant role in understanding the behavior of materials, objects, and fluids in motion or at rest. The density of a substance influences its buoyancy, stability, and other physical properties. One definition of density. Density, rho, Greek letter rho, is defined as the mass per unit volume of a substance. Mathematically, it is expressed as rho equals m over v, where rho is the density, typically in kilograms over m cubed or g over centimeters cubed. Mass, m equals mass of the object in kilograms or grams, and v is the volume of the object in cubic meters or cubic centimeters. 2. Units of density. SI unit of mass is kilogram, kg. SI unit of volume is cubic meter, m cubed. Therefore, the SI unit of density is kilogram over m is kg over m to the third, or m cubed. Other common units include g over centimeters cubed and kilogram over and kg over L. 3 types of density. 1. Mass density. The most commonly used form referring to how much mass is contained in a specific volume of a material. 2. Linear density refers to mass per unit length, commonly used to describe strings, rods, or wires. Formula: lambda equals m over L, where lambda is the linear density, m is mass, and L is length. 3. Surface density refers to mass per unit area used to describe thin sheets or surfaces. Formula: sigma equals m over A, where sigma is surface density, m is mass, and A is area. 4. Density in fluids. In fluid mechanics, density plays a crucial role in buoyancy and fluid flow. The buoyancy force on an object submerged in a fluid is related to the difference in density between the fluid and the object. Archimedes' principle states the buoyant force equals the weight of the displaced fluid, and the object will float if its density is less than that of the fluid. The continuity equation in fluid dynamics also relies on the concept of density, particularly when describing incompressibility of fluids, for example, water in flow. 5. Density and material properties. Homogeneous materials. In materials where density is constant throughout, it is uniform across the entire object. Heterogeneous materials. In materials with varying densities, density may change depending on location or composition. Density in states of matter. Solids typically have a higher density than liquids, and liquids have a higher density than gases. 6. Role of density in classical mechanics. 1. Mass and weight relationship. The weight of an object is the force exerted on it due to gravity, and it is related to the density of the object and the gravitational acceleration, g. Weight equals mass times gravitational acceleration. 2. Inertia and motion. Density impacts how an object resists acceleration. An object with higher density has more mass packed into the same volume, making it harder to accelerate. 3. Elasticity and stress. Density can affect the elastic properties of materials, for example, how much an object deforms under stress. Denser materials tend to be less compressible, which affects how they respond to external forces. 4. Energy considerations. In terms of potential energy, gravitational potential energy involves mass, which is directly related to density for a given volume. The more dense an object, the more mass it has, and thus the higher the potential energy it possesses in a gravitational field. 7. Applications of density in classical mechanics. 1. Fluid mechanics. Buoyancy, pressure, and flow calculations depend heavily on density, especially in the study of fluids and gases. The ideal gas law also involves density in determining the relationship between pressure, volume, and temperature. 2. Structural mechanics. In designing structures, buildings, bridges, etc., knowing the density of materials is critical for understanding how they will behave under load, for example, how they compress or stretch. 3. Thermodynamics. Density is important when analyzing the thermodynamic properties of substances, including their specific heat and the behavior of gases under various conditions of temperature and pressure. 4. Vehicle dynamics. In the case of transportation, airplanes, cars, ships, density influences speed, stability, and fuel efficiency, especially in terms of air or water resistance. 8. Density In gravitational systems, density is important when studying celestial bodies like planets, stars, and black holes. For example, the density of a planet determines its gravity and whether it can retain an atmosphere. Similarly, the density of a star is a determining factor in its life cycle. For example, whether it becomes a white dwarf, neutron star, or a black hole.